Today we're in sections 2.4 and 2.5, multiplying and dividing rational numbers. All right, so in example 1, we're looking at multiplying rational numbers. The first one, it's a decimal. The second one, it's a fraction. So let's focus first on the decimal value. Now here is my advice to you. Do not, go ahead and just decide what the sign of your answer is before you even multiply or divide. Is your answer going to be positive or negative?
Negative on the first one.
Okay, on the first one, all right, who would say my answer is going to be negative? All right, then you are correct because I only have one negative, so my answer is negative. That's the only thing that plays into this, all right? I would encourage you to multiply or divide your absolute values, meaning ignore the sign. You know that your answer is negative, so now don't worry about the sign. Just go ahead and multiply the numbers like you would normally multiply decimals. 2.5 times 3.6. We line them up vertically. And remember, we are not lining up the decimals as much as the digits. We line up the digits. You guys remember that with multiplying decimals. All right, and now we're just going to multiply. 5 times 6 is 30. 2 times 6 is 12, plus 3 is 15. What do I need on my second row as a place value holder? Anybody remember that, Elijah? A 0, okay? And now I can multiply. 3 times 5 is 15. And 3 times 2 is 6, plus my 1 is 7. Now I can add these together, and my answer is 900, right? Is my answer 900? Okay, how do I know how many decimals go in my answer? Yes, ma'am, Abby. Very good. In my decimal values that I multiplied, I had 2 decimal values, so that means I have 2 decimal places in my answer. But remember, okay, so this is just a little reminder part, is my answer positive or negative? It's negative, so tack that negative on to the end, and your answer is -9. All right, and this is how we would multiply any of your decimal values. So on your homework tonight, this is how you do it. Just line up your digits like normal, multiply your decimals, and then decide at the end if your answer is positive or negative. The only thing that's different here as opposed to probably 4th, 5th, and 6th grade is that my answer is negative, okay? All right, multiplying fractions now. What have we said about mixed numbers? What do we need to do to them before we multiply? Tommy? Make them improper. So now I have -1/3 times negative, and that's what, 11/4? Does everybody agree with that? Okay. All right, so before I multiply, okay, again, I'm going to say what I did in the first problem. I'm not going to worry about my signs and what's positive and what's negative because I know that my answer is what? Positive or negative? My answer will be positive. Now the signs are irrelevant. I know that my answer is going to be positive. You don't have to worry about multiplying. Oh, what's negative this times negative that? Don't worry about the negatives when you're actually multiplying. You know that your answer is positive. Now just multiply the numbers, okay? So is there anything we always want to check, and we're going to see this later in the lesson, is there anything that I could cross-reduce between the 1 and the 4 and the 11 and the 3? Any factors that we could reduce those numbers by? No, there's not. So I'm just going to multiply to get 11/12. All right? So we always want to check to see if we can cross-reduce. And just as a reminder, is my answer positive or negative? Positive. It's positive. All right, so really one of the main ways that you can easily get tripped up on your positive and negative decimals and fractions is when you try to multiply negatives and positives together and you have to remember all your signs. You don't have to do that. You can just look at the original problem. I'm multiplying 2 negatives, so it's going to be a positive answer. All right, it's so much easier to look at it separately like that. You guys kind of see how I'm splitting that up? This is how I figure out the sign of my answer, and then I just multiply and divide my numbers. All right, you guys with me so far? Following along? Okay. All right, so in example 2 now. Now we're going to switch gears and we're going to divide rational numbers. What does that mean? That just means that they're not going to be like even numbers or whole numbers, integers, that type of thing. All right. Now, the other day we talked about, and I know that's been since probably Thursday that we talked about this, but does anybody remember how do I know which number goes on the inside versus the outside of a long division symbol? Does anybody remember how I determined that? All right, I'm going to set this up over here. The first number or the top number. Okay, so you might want to kind of write that down in your notes if you need that reminder. The first number will always go inside. No matter if it's smaller, bigger, it does not matter. The first number goes inside. And the second number goes outside. Okay? Oh, wait, but I forgot my negatives. But remember what we said in example 1. I know before I even divide anything, is my answer positive or negative? Positive. It's positive. Okay, so that's it. You don't have to worry about your signs now. Now you can just focus on the numbers. But wait, can I divide decimals? Okay. No, I mean, I could have a decimal on the inside, but not the outside. So how could I move my decimal out, JD?
You just move it over to the right, and then however many places you got to move, you move the one on the inside.
Very good. This is my focus. How many decimal places do I have to move to get that decimal out of the number? And how many is it, guys? 1. So because it's 1 on the outside, it's 1 on the inside too. So I'm essentially just erasing my decimals. Okay, what I did was I basically multiplied them both by 10, which eliminates the decimal, but I haven't changed any values. Now I can do long division. All right, go ahead and do the long division in your notes. This is something that we did the other day, a little bit of long division. All right, so go ahead and divide these two numbers. Okay, 36 goes into 84 how many times? 2. Okay, that's going to be 72. Subtract them, you get 12. Does 32 go into 12 any? No. Nope, so I add my 0. What about 36? 36 go into 120? How many times? Do you agree? 3? Okay, so bring that decimal up into your answer, and I have a 3. 3 times 36, I get 108. Okay, and I bring it down and I get a 12. Here is my first indicator that I may have a repeating decimal. I see my remainder repeat. Okay, so that tells me I might have a repeating decimal here because 36 goes into 120 how many times? 3 again. And guys, we could do this all the way until the screen touches the floor, right? 3 times, what now? Does somebody, okay. 3 times 36 is 108. Subtract 12, and then I'm still basically spinning my wheels, right? All right, so I know that the 3 is repeating. Once you get out 3 or 4 decimal places, it's very obvious whether or not your answer is repeating. All right, so I would say this is probably the most tedious part of the lesson is anytime you run into a repeating decimal. Other than that, your decimal problems are pretty basic, pretty simple. Now, we talked at the beginning of the lesson about dividing fractions. All right, so refresh my memory. What method do we use to divide fractions? It's called the KFC method, which means keep the first fraction, flip the second fraction, and change your operation. So instead of 6/5 divided by -3/4, I have 6/5 times 3/4. Is my answer going to be positive or negative? Negative. So don't forget that in your answer, but it's not involved in the multiplication. Is there anything I can cross-reduce? Okay, so here's my advice to you. You will not be deducted if you miss the cross-reducing. But here's what's going to happen. You get to your answer, you don't have calculators on this quiz. Okay, so if you get to your answer, all right, and your answer is like 236 over 420, then that's going to be kind of hard to reduce using mental math. All right, so that's why cross-reducing really helps you because it keeps your numbers small. If you cross-reduce everything, odds are when you get to your answer, it's already completely reduced, 3 and 2. So now you just have 9/10. 9/10, and that's it. Okay? All right, questions on dividing fractions. It's literally the same thing as multiplication. Did I do something wrong? Oh, yeah, it's negative. It's negative. Very good. All right, so again, just double check at the end and just make sure you've got your sign correct, and then it's just negative 9/10. All right, so same thing as multiplication, except we just do KFC. All right, guys are doing well. Oh, my goodness. Okay, look at this one. Negative 1/7 times 4/5 times negative 7 times negative 1/2. You're going to have questions like these on your quiz and your test. And if you choose not to use your number properties, it can be a real pain, okay? But number properties give us, what do I have written in parentheses?
Shortcut.
Shortcuts. Who likes taking shortcuts? Anybody? Or is that just me? I love shortcuts, okay? Because why do all the hard work when I can just take the easy way to the answer and get the answer right every time?
What are shortcuts?
No, shortcuts are usually pretty easy, okay? So, what property says I can rearrange my numbers? What property says I can rearrange my numbers in any order? I heard it. Commutative. The commutative property. So I want you to look at this expression and try to find maybe some that you would want to match up together. Okay, just look at it. Don't say the answer out loud. Okay, it's a open game. All of them are open game because it's multiplication all the way across. So I can rearrange them in any order I want. I could multiply them left to right, but maybe there's an easier way. Maybe there's some that I could match up. Anybody see anything that you could match up? Micah, what do you see? I'm sorry? I would probably match those up together. Probably not first. Probably not first. Anybody else see it? Or even looking at the screen? Hayden? Paying attention? Okay, anybody? You see what you would match up?
The 1/2 and the 1/7.
I would do negative 1/7 times negative 7/1. Wait a second, I didn't see 7/1. Well, that's a whole number. Whole number can be over 1. What do you see now that we wrote it that way? It was canceled, right? Now all I'm left with, yeah, that becomes a 1. Now all I'm left with is 4/5 times negative 1/2. All right, and remember, we're not worried about the signs because we can go back to the original problem and count our signs. All right, so it's just 4/5 times 1/2. Can I cross reduce anything? Yeah, I can cross reduce. 2/5. Now, let's go back to the original problem. How many negatives do you see in the expression? 3, so that's an odd number of negatives. So that's a negative answer. Negative 2/5. So much easier, guys, than multiplying 1/7 times 4/5 to get 4/35. Wouldn't that be? And then to multiply that by negative 7 and then to take half of that. Instead of doing all that work, it literally took hardly any brain power at all to match up my opposites. Okay? So you just have one of those. I mean, there's one. On a quiz test, it's one. Okay? So if you get it wrong, it's not the end of the world, but if you know your shortcuts, you really should get it right. Okay? I think you have 1 or 2 on your homework tonight. Any questions? All right, so that's it for the multiplication and division part of it. Now we just need to look at a couple interesting looking problems, and then we'll be done. Evaluating a complex fraction. What do you notice is different about this? What's different about this?
It's got a division line in the
It's a fraction on top of a fraction. Okay? So here's what you're going to do when you have a complex fraction. You will follow this process every time. Okay? Here's what you do. Negative 10 over 9 divided by negative 1/6 plus 1. It's important that we keep our signs for now in the original problem. Okay? So what I'm doing is I'm dividing, I'm just putting it into the horizontal method. Okay? And I know that this goes in parentheses because I can't add them together as they are right now because they do not have what? What do fractions have to have in order to be able to add? They have to have a common denominator, okay? Well, how can I make 1 into a fraction that would match up with negative 1/6? Multiply it by 6, right? I can make a whole number, any fraction, right? 5 over 5, 8 over 8. Well, I wouldn't do any of those numbers because they wouldn't match up with the denominator. I need to make it what, guys? 6 over 6. Okay? I need to make it 6 over 6. So now, what's negative 1 plus 6? No. What's negative 1 plus 6? Divided by 5/6. All right, you should get this now. This is just division for fractions. Go ahead and divide. All right, so I've got negative 10 over 9 times 6 over 5. Well, that makes it nice. Once I flip it, what do I see? I see a bunch of areas I could cross-reduce. Now, don't worry about the sign. Is my answer positive or negative at this point? It's negative, okay? So just put the negative in your answer. So don't worry about the signs. Now just reduce. Okay, this reduces to a 2 and a 3, and you get negative 4/3. You can leave it improper as long as it is reduced. Can you reduce 4 and 3 anymore? No, you can make it negative 1 1/3. That would be okay, but you don't have to. 4/3 is completely reduced. That's your final answer. All right, and yeah, so this is kind of like a real life example. Of course, they always put these in our lesson. It says the school record for the 40-meter dash is 15.24 seconds. Predict the school record after 15 years when it decreases by 0.0 seconds per year. All right? So I want you to visualize this for a second. Okay? It is 0.06 every year for 15 years. So what do you see when you visualize? You just see 0.06 15 times, right? Okay? So instead of writing 0.06 plus 0.06 plus 0.06 15 times, how can we show that in an expression? Instead of adding it to itself 15 times, we can, I heard it, guys, we've been doing it in this lesson. We can multiply. Okay? So we have 15.24 times 15 times, if it decreases, what's going to be the sign of the number? Negative 0.06. All right, I want you guys to go ahead and try to evaluate this, okay? So we are going to, I'm sorry, this is not a time sign, this is a minus sign. You're subtracting the product of 15 times 0.06 from the original record, okay? So what you have to do is you multiply this part first, and then you subtract, okay? So now that I've multiplied it, 15.24 minus 0.9, okay? 4, borrow, 3. Here's the new record. If it decreases, and for whatever reason, Maybe they have faster suits, or who knows. Seconds. No, that's after 15 years. That's going to be the new record. Okay? All right, just plugging these concepts into a real life type of scenario. Okay, this one's on your quiz, so it's important. All right. Restaurant launches a mobile app to allow customers to rate their food. -5 meaning it was terrible, and +5 meaning it was awesome. I don't know why they chose the scale. Okay, so far, here's their ratings. Okay, so you need to write their ratings down. Someone scored a 2.25. Someone scored a -3.5. Ooh, they didn't like it. Someone did a 0, kind of indifferent, somewhere in between. Someone said it was really, really bad. Someone said it was kind of good, maybe better than average, and not good. I think anything in the negative would be not good. And then you've got 3.5. Yeah, they really liked it for some reason. Maybe they liked the ingredients in there. And then you have -2.5. Okay, so here's what you need to do. Community of property is so important when you're finding the mean. Okay? It's so important. You want to pick out your positive integers and your negative integers and group them together. So 2.25 is positive. 0, I'd say, is really indifferent. That's not going to matter. 1.75 and 3.5. And I'm going to add all my positives together. All right, so I go 2.25. 0. Do I need to put the 0 in there? 1.75 and 3.5. Okay, so there's all my positives. I add those together, and then I take all my negatives. 3.5, 4.5, -1, 1.0, and 2.5. And remember, with negatives, I add and keep my negative at the bottom, okay? So let's add and keep both sets now. And this is how you're always going to solve these. Group your positives together and group your negatives together. And you add and keep for both sides, and then you take the difference. All right, go ahead and find the sum for both of these sets. What's the sum of the first set? Okay, so everybody agree it's 7.5?
Yes.
Okay, and then what's the sum of the second set?
11.5.
Okay, so here's what I have. 7.5 minus 11.5. What's 7.5 minus 11.5?
4, -4.5. No, -4.
All right, it is -4. Good job. It's not my answer. It's not my answer. This is the sum, but in order to find the mean, what do I have to do? Divide it by what?
The numbers end up
1, 2, 3, 4, 5, 6, 7, 8. So the mean is -1/2. Okay? So you found the sum, but then you had to divide by the number of numbers in the data set. That's how we find the mean, and that's why we get -1/2. And you've just survived section 2.4 to 2.5 lesson.